Now, if you look at the structure of coronavirus, most viruses are two types. Some viruses have membrane, some do not. So coronavirus is a virus which has a membrane. So around it, it has a lipid membrane. Oils surround the virus and keep the material inside. So their membrane is not protein or something else. It is only lipid. The red ones, you recall, it's what's called, they are protein, spike proteins they call. So the red ones are spike proteins, but here we have the lipid membrane. So if you have a lipid membrane, soap and alcohol are good materials to get rid of the virus, because as we have seen, soap will think that virus is a dirt. So since the gray membrane is nonpolar, the soap molecules will come here and then stick the nonpolar ends, the oil ends, into the virus. And the moment they insert their nonpolar tail into the virus, then the membrane breaks apart. The virus just breaks apart and it's destroyed. Then you wash it, it goes away with water. So soap is very effective for disrupting the surface or breaking apart the coronavirus. Same alcohol. Alcohol also ruptures and breaks away the lipid membrane of the coronavirus. Then we get rid of the virus also with the dirt, because some of the virus can stick onto dirt or oil on our hands. So we get rid of them both by using soap or alcohol. Now here we see how it works. These are the soap molecules, nonpolar and polar heads. These are the spike proteins. This is the lipid membrane, and this is the genetic material. So when the tails of soap molecules stick into the membrane of the virus, then it's not an active virus anymore. It just breaks apart. Now, if we look at the content of the sanitizers, which we always use during coronavirus, I don't know, we don't use it anymore, I guess, maybe we should. Mainly it's alcohol. It's 60 to 95% of the ingredients are alcohol, and mostly it's ethanol. And then we have some isopropyl alcohol and some propyl alcohol. And they also contain some hydrogen peroxide. You know, hydrogen peroxide also kills bacteria and viruses. And glycerin is used just to humidize your skin, because alcohol removes some of the oil on your skin, which you need some oil. Your own oil, your own fat on the skin to keep it soft. Therefore, you have to use something like glycerin to keep the skin moist. It shouldn't be too dry, because alcohol takes away water also. And soap takes away oil. Therefore, you have to have something, a cream or glycerin on your skin to keep it humid. It's a moisturizer. And also, they put some thickening agent, that is to make sure that the sanitizer does not just flow away easily. Just a bit of thickener they use. Now here we give the details of the sanitizers. As you can see, we have the ethanol, N-propanol, and isopropanol, and some of the other ingredients. And it tells you, I have told in previous slides, this is virus, how it attacks virus. This is the bacteria. As I said, bacteria has protein membrane. So alcohol denatures the protein membrane and kills the bacteria, and also it ruptures the virus's membrane, and destroys it totally. So this is the recommended by the health centers of preparing, because you cannot sell any kind of sanitizer direct. You have to, of course, get permission from the government, but they recommend that these are the percentages. Active agents are 60 to 95% is alcohol, ethanol, isopropyl, and N-propyl alcohol. These are the supporting materials, hydrogen peroxide and glycerin and thickening agent, etc. And you can sell it in gel or liquid or foam form, they say. But of course, you have to get permission from the medical authorities of each government. Tabi bizde hile yapanlar oldu maalesef. Okay, now when we use soap to clean our hands, I am sure you noticed that when you go to Antalya or some cities, when you wash your hands, the soap seems like staying in your hand because the water is salt water. But in Ankara, we have hard water. There's too much calcium in our water compared to Antalya and some other countries now. Now, what happens if I have soap, sodium salt of soap? Var mı burada yazdık mı böyle? Okay, I have here the sodium salt, which is soap. Now, if I have calcium ions, what happens? The calcium ions replace sodium ions. Or maybe you can have another one. So when it's replaced by calcium, then you have calcium, let's say, stearate. This is soluble in water. This is insoluble. It's called in English scum. Scum dediği sabunun oluşturduğu çözülmeyen beyaz madde. So you produce a compound, calcium stearate, let's say, or other palmitate or whatever, but they are insoluble in water. And they precipitate as a white precipitate. I don't know if you had any problem in your kitchen that the sink does not accept any water, then the sink fills out. Oldu mu hiç evinizde lavabo tıkandı mı? Ya da yurtta? Olmadı. Olur bir gün. So when you call the handyman to fix the sink and the water which doesn't flow away in the sink, he just opens up and then you can see the white precipitate there. That is precipitation of calcium stearate or other oils, other carboxylic fats. It just clogs up the drains of the kitchen or bathroom sinks. By the way, do you remember the video of the guy who bought Twitter? He had a sink in his hand. Did anybody explain to you what it was meant? I didn't read anything in the papers. Elon Musk had carried when he entered the Twitter building with the sink. I didn't hear anything which could be a reasonable answer. My answer is very simple. There is a saying in Turkish. It says, went down the drain. Went down the drain. Yani ne diyelim lavabonun içinden aktı gitti. Down the drain. Drain dediğimiz işte pis suyun akıp gittiği yol. Yani diyor ki, he says that I came here, I am the boss now, you all will go down the drain. Hepinizi süpürüp atacağım. But I didn't see anything in the American papers or in Turkish paper. Yeah, you have a saying, yeah?
Maybe he made a pun.
Hmm?
Maybe he made a pun.
I think they were saying also, let that sink in.
Yeah, that's the pun.
They were joking like, let that sink in.
Maybe, but that's my solution. I would prefer my solution because you'll all go down the drain. Because for people, they use that word. He just went down the drain. Yani attık gitti, süpürdük gitti. Okay. So, if the drain doesn't work in the sink because the soap forms calcium stearate or other compounds. Also, same thing happens with the oil also. Also, when you pour too much oil, and also you pour vinegar, whatever, so some of the oil or fat also accumulates with the dirt. So if you pour too much oil or fatty dirt into the sink, after several years, you may have a clogged up drain. But mainly, the soap. Detergents do not have that problem. When you use too much soap, you have this difficulty, but if you use detergent, you don't have that problem. I'll show you why. So if we use soap in a place with hard water, soap still cleans, but some of it is converted to calcium, so it's not as efficient as when you use soap in a house with soft water. Now, I mentioned about soda. I said that in the old days, our mothers and grandmothers used to add soda to the washing machine, or also to when they wash the dishes. But especially in those days where they didn't have washing machines, because when Turkey started to use washing machines, they used some detergents, but some women used to just put some soap, which is not good for the washing machine, because of this problem, you can also harm the washing machine because it clogs up the hoses in the machine. But of course, it was cheap, it was more available. The detergents were a little expensive. In the early days, most of the women in Turkey used to just grate, to take the soap and then break it into pieces and then fill up the machine, and also it gives out some foam, and you do not want foam in dishwashers or washing machines. Well, anyway, so soda was being used along with soap in the old days because soda helped to clean the heavy dirt, not ordinary dirt, but heavy dirt. But of course, soda was very expensive because in Europe they didn't have soda sources. Soda sources are limited to certain countries. Now it's cheap, but in those days you could only obtain from various countries. Like I said, Mesopotamia, they had to import from one lake, from Anatolia. And also soda is important to make glass, window glass. You use soda. Why do we use soda to make glass? Soda. I said that quartz has the highest melting point, very high melting point. So to produce glass, ordinary glass or soda glass, you have to reduce the melting point. You have to add some other minerals into the mixture of silicone, because you produce glass from just sand, right? Ordinary sand. Of course, not any sand, but they know which sand has higher silicon content, because some impurities they don't want to have in glass. For instance, iron makes the glass look green. In the old days, most of the bottles in Turkey were green. Nowadays, they don't have it because of the iron. So some window glasses even were a bit tinted green because of the presence of iron. Now, in physical chemistry, you should remember that if you have a pure compound with a very high melting point, when you add something else into it, the melting point reduces, lowered. Do you remember anything from physical chemistry? No? Freezing point depression, melting point, boiling point elevation. Freezing point depression, boiling point elevation. Fizikodan A alan kim?
I mean, yes, this is that. No, I mean,
Can you explain? Okay, let's get back to physical chemistry. When I say boiling point elevation,
they are colligative properties, they are proportional.
yeah, okay, the colligative properties is the name, but explain the basic principle, why it happens.
I guess it disrupts the lattice
Of the crystals?
that pure compounds forms, and therefore it requires less energy to
Yeah.
melt.
Yeah, so that's called freezing point depression or melting point depression, same. Boiling point elevation is something else, but it's similar property. So he says if we have a pure compound like the silicon dioxide, we have some crystalline forms. So if it is pure, then it has the highest melting point. Now, anybody worked in organic chemistry lab with a professor as an assistant or helper, whatever? Does anyone do research in organic lab? With whom do you work? Huh? Okay. When you produce a compound, organic compound, you measure the melting point, but he says crystallize it one more time and see what melting point is. You right? Did you do that ever?
And can you repeat?
Yeah. When you produce an organic compound, synthesize, if it is solid, Özdemir will tell you, go and measure the melting point. He would say the melting point should be 98.5. And you come up and you say, sir, it's 89.9.
I understood that it's not pure.
Yeah, he said, go back and recrystallize it, okay? So you get rid of the impurities because you do not want any impurities in the crystal. It reduces your melting point. That's why you recrystallize it several times to obtain the purest compound. When you see that the melting point of your compound is exactly the same with the melting point given in handbooks, then you can be sure that it's pure compound. Okay? So, if we have silicon dioxide, the sand, its melting point is, I don't remember, but can somebody look at it? The melting point of quartz, maybe about 1800 degrees, I don't know. But if you add an impurity, suddenly the melting point decreases. So soda is the most common compound that we add to quartz to produce ordinary glass.
Hocam 1700 gibi.
Yeah, I thought it's 1700 something. So can you look at the melting point of soda glass? It's much lower. And there is another glass they call Pyrex. Does anyone know the difference between soda glass, Pyrex, and quartz? We talked about quartz, that's okay. It's pure silicon dioxide glass. Pyrex,
Is it soda lime glass?
doesn't matter, soda glass, soda lime glass.
Bean.
Huh?
Bean.
Yeah, 1000. How about Pyrex? Pyrex glass, melting point of Pyrex glass. So let me write down so that you will remember in future.
Ya 1250 gibi bir şey gördüm. Mesela.
Doğru. Bir 750 falan mıydı? Kaçtı?
Kuart mı?
Kuart.
1700 civarı.
1700.
İki formu vardı. Biri 1680,
Tamam.
biri 1713.
Anyone knows what it contains? Another element, not soda. Pyrex.
Is it the bor one?
Borosilikat. Borosilikat is borax. Çok mu aşağı yazdım, okunuyor mu?
Çok zor.
Ayağa kalk bak, eğer kapatayım mı bir şey?
Şey gördüm hocam.
Gördünüz mü? Şunu azıcık açarsam. In the laboratory, you use only quartz cells in one instrument. Which one? UV. If you use soda glass or Pyrex, you cannot obtain the proper spectrum. But for other purposes, for instance, for ESR, you don't have to do it. But UV, you have to be careful to use quartz cell. Okay, now, so soda was being used to produce ordinary glass, and also it was used for women to wash their clothes better than soap. It was expensive because it was being imported. He discovered a technique to convert sodium chloride to sodium carbonate. Then the prices went down. So when the prices went down, of course, it influenced the ladies at home or factories who use soda along with soap, washing houses or just ordinary women, because soda was important for them to get rid of the heavy dirt. Now, of course, chemists were always trying to find a way to make sure that to use something like soap, which is not influenced by hard water, because they couldn't clean the textiles or dishes properly in hard water, because soap did not work 100%. So they were looking for alternatives. Soda was one of the alternatives, but it was not enough. Something else they had to find to make sure that it worked in case of having hard water. they used, that's why I mentioned soda glass. They started to sell soda glass as a supplementary material for washing, soda glass, sodium silicate. They were selling a mixture like that. So anyway, the chemists finally found a way to use not sodium carbonate to make soap, but a compound which would not have any sodium, because sodium replaces replaces sodium, so you have calcium stearate. So you have to have something. Calcium stearate is insoluble in water. So they produce another material where instead of carboxylic acid or carboxylate material, they use sulfonate. So if you have sodium sulfonate as a surfactant or detergent, even though when you work with the hard water, if you have calcium here, calcium sulfonate dissolves in water. So that's why detergents are more efficient than ordinary soap, because soap becomes partially inactive when you use hard water, but detergents do not, because even if you have calcium, the calcium salt is not insoluble. It doesn't form a scum like soap. Here we have the soap in the bottom, as you can see. When we replace this with calcium, it precipitates, white precipitate, insoluble. But if I replace this or that, doesn't matter which kind of detergent you use. If you replace it with calcium, doesn't matter. And also, it's hard to replace the sodium there in sulfonate with calcium. Now, let's say something about the perfumes. Is there any question about soaps and detergents before we go further? Okay. Now, we know that perfume industry is very wide in the world. Even in soap and detergents, they put perfume because it sells better if you have a good perfume, because your dress smells nice or your hand smells nice. So they use perfume everywhere. Now, but before human beings used perfumes, they noticed something, because they invented how to keep fire continuous in their caves. Fire was always there, because when you have some meteors falling down, or in a rainy day when you have some what do you call lightning? Yeah, lightning. It catches fire. So fire was always there since the beginning of Earth, but you didn't know how to control it, how to transfer it. So about a million years ago, the caveman or the primitive man discovered how to control the fire and how to keep it running. They were living mostly in caves, but not always in caves, but small houses, half underground, half up, down, but let's say cave or something like that. So they had the fire on at the entrance of the cave. That kept the wild animals away, and also it kept the cave warm. And they also discovered how to cook food, because they ate meat just uncooked. Of course, they had no chance to cook. So fire was important for them to prolong their lives, because if they didn't have fire in front of the cave, probably a wild animal would come and then kill everybody in the cave. So they prolonged their lives. And then when they cooked with the fire, they had healthy food, because they killed the bacteria by cooking. But anyway, but they noticed that some wood, they were burning wood, of course. When they burn wood, some of the woods from certain trees smelled real nice. Of course, human beings, I mean, if they are caveman or primitive man, they are not dumb, they are not animals, they are human beings. So they liked it. And they kept, probably, I mean, that's scenario, probably we say that they kept them away. They burned it on special occasions because probably those trees were rare, not very common trees. So when they found the tree and when they burned the wood, if it smelled good, they kept it away. So it was the beginning of incense. Ne diyoruz Türkçe neydi? Hani yakıyoruz, güzel kokuyor. Ne? Tütsü. So it was the preliminary incense. Perfume, of course, goes back to Sumerians, but before the development of perfume, much earlier than Sumerians, they used incense, we know, but China seems that they used it in Neolithic times, but we don't have any evidence, definite evidence at what time. But we know that around 2000 BC, they used incense in religious ceremonies in China. Now, incense became very popular all over the world. Did I give the details? Oops, atladım mı ben? Yeah, in religious ceremonies. Yeah, it was used in 2000 in religious ceremonies. And then it was transferred, the idea was transferred to India and Egypt and other countries. Now, when Sumerians invented the distillation apparatus, of course, they changed the entire world. Of course, in those days, when we talk about the entire world, we are talking about Mesopotamia and Egypt. In China, they didn't have distillation apparatus at that time. In Egypt, we don't know, because we did not see any distillation apparatus similar to Sumerians from the pyramids of Forah yet. Maybe one day they can discover it. Okay, now they also discovered, as you know, the extraction apparatus. So you can use both the distillation apparatus and the extraction apparatus to make perfumes. So we see that there are some tablets written by Sumerians and Babylonians and later perhaps by Akkadians, whatever, giving the description of preparing perfumes from plants and some animal parts. And the first time that we see a written document, we have the distillation apparatus from 3500 BC, 5,500 years ago, but we never found so far any clay tablet mentioning about the distillation apparatus and the distillation directly. We know that they carry out certain processes, but first time the word distillation was used by a woman named Taputi. She well, not her, but about her perfume making, we have a document which mentions about 2000 BC that she worked in palace of king of Babylonia. I don't know if it probably Hammurabi or maybe just a little later than Hammurabi. She used various plants, and the clay tablet mentions that she used various materials. Let me read it here. It says, she used flowers, oils, kalamus, eğir kökü, myrrh in Turkish we call it. Myrrh we will see a lot later on because myrrh was very popular in Egypt. Still they use it. Balsam, kına çiçeği, and some aromatic plants. They didn't give the names. She added water and other solvents, then distilled the mixture. So this is the first time at 1200 BC that we see the word distillation. Sumerians carried out distillation, but they did not use this as a special procedure. This is the first document that says distillation. Of course, not in our words, but Sumerian, Babylonian language. Now, we also found in Cyprus, northern Cyprus, Pyrgos, which a perfume production laboratory from 2000 BC. Of course, there is no written document so far, but the laboratory was there. It proved that it is a perfume production plant. This is the carving of Taputi. As we say here, she is the first perfume maker by name, by known name, and this is the first time that distillation process was mentioned. Now, another Sumerian tablet gives some details about making perfumes. I will read it down, but it's not easy to understand because in those days, as I said, they did not use comma or dot, so the sentence continues maybe for a whole clay tablet, one sentence. But if you are expert, if you are Sumerian, you can understand where the sentence ended, where it began, but we would never be able to understand. It says, on the fourth time of pouring together, you heat fresh, good, well water and pour it into hirshu pot. The mixture stands overnight and is steeped. In the morning, you filter the water and aromatics using a cloth sieve in other hirshu pot. Remove the dregs, the junk, the dirt, whatever. Then you measure 3/4 of calamus, 3/4 of expressed filtered myrrh, and these are aromatic plants, and do as done earlier with the calamus and myrrh. Light the fire. When the water necessary for the mixture is heated, pour the oil and stir. Then the oil, water, and aromatic penetrate to one another. You need not to shake them further. Cut down the fire under the dikaru pot and let it stay for 2-3 days. Yani bir su fazıyla yağ fazı dengelensin diye. Tabii dediğim gibi anlaması zor ama we understand that they use plants and they used oil because we use some oils together with the perfume. So this is the one of the very rare clay tablets which tells you how they produce perfume. We don't understand how they did it, but we know the ingredients at least. Okay. Now, there are some paintings on the walls of the pyramids, Tutankhamun and other phoras. When you look at the woman on the wall paintings, you can see these cones on their top of head. In the beginning, they were thinking it was some kind of conical hat. It's not hat. They discovered that what they have here is beeswax, balm, mixed with perfumes. So she puts the beeswax cone on the head, which contains perfume. Since it's very hot in Egypt, as you walk away around, it slowly melts and wets your hair. Your hair smells good. So that is there are many photos. If you just enter the Google and ask beeswax cone Egyptian woman, you can see many drawings. Now, we mentioned about Abbasids and Umayyad caliphs, and their palaces had many chemists. They worked in their laboratories, and one of the famous chemist was Al-Kindi. He was born in Kufa, Iraq, around 801 AD, and he became a world famous scientist, chemist, and also he was the doctor of the Abbasids. And we are talking about him because he wrote a book. It says, the book of the chemistry of perfume and distillation. So when this book and similar books were translated into Latin and then to other languages, Europeans learned that there is something like distillation. They learned that there is something like perfume. Only after the Abbasids, this is 801 AD we are talking about. We are the Sumerians 5,000 years ago. This is only 1,200 years ago. So Europeans didn't know anything about chemistry, as I mentioned before. But as I say always, they are not stupid. Just because of the ice age, when the world was covered with ice, and then of course it started to melt in the Ecuador. So civilization flourished around Ecuador, around Mediterranean. So people in the north, they didn't even see the ground. They were just trying to live, that's all. They didn't care about chemistry or anything. They just wanted to live, stay alive. And the number of people lived there was very, very small. Very few people lived there. So they had no chance to get together and create new knowledge. Okay. Ibn Sina, Avicenna, also you all know Ibn Sina Hastanesi, everything. He was born in Bukhara, or Buhara, we know today. And he became the most famous and most respected doctor in the world. For hundreds of years, his books were used in Sorbonne. His books was used for hundreds of years, several hundred years, not 10 years, 20 years, several hundred years they used the book. That was the only book they trusted. Because he said that without using the medicine on the animals, please do not attempt to use it on humans. So Europeans never thought about it. I mean, they made something else and they just said, eat this or drink this, you'll be all right. But this is the first time that someone says that, please make sure that the medicine does not harm living creatures. So try it first with the animals. He wrote many, some of the prescriptions he gave for various diseases are still assumed to be correct. We do we use similar techniques and similar medicines that he used. But we are not talking about his medicinal success, but we should talk about the perfume. So he produced rose oil for the first time by steam distillation. Still today, we produce in factories rose oil and rose water by steam distillation. Vermiştin değil mi steam distillation? Where do we produce the most rose oil and rose water? In which city? Sparta. Okay, yeah. So they have many factories, very big steam distillation apparatuses. They export to entire world, especially to France, because they use, when you make a perfume, it's not only one or two herbs, maybe 50, 60, 30 different herbs, and always they use, in most of the perfumes, they use some rose oil. When we talk about Jabir ibn Hayyan, or El Jabir, he is also the best chemist known who influenced the entire Europe because he invented many chemical processes. But of course, we can say he reinvented after the Sumerians. Now, we never know how come the Abbasids or Umayyads started to carry out chemical reactions and work with steam distillation, extraction, etc. My theory is that possibly after Sumerians, since everything disappeared, but some knowledge did not disappear totally from one mouth to the other. One father told his son, he told his nephew, he learned from his uncle, whatever. So probably the verbal transformation stayed there. But those chemists, since they didn't write any book, we don't know about them. That's my theory. But when somebody started to write books during Umayyad and Abbasid time, because the Sultan or Caliph wanted them to write books. The first, they translated, unfortunately, as far as I am concerned, the books of Aristotle. They called him the best, the top scientist. They respected him. But they didn't know that he prevented experimentation to the scientists. Aristotle said, don't do experiments. You can find the solution to everything. You can find answers to everything just by thinking and discussion. But because he wrote the books, Aristotle wrote the books, so they translated them all. But it was not enough, and they couldn't learn anything from them, not much. Then they gathered all the people who know something about science, something about medicine, and they said, write books, write your experiences, and that's how it flourished in Umayyad and Abbasid palaces. So, as I said, he became the most influential chemist in the world because of his books. Now, I have here some statements about the history of science historians. Historian of chemistry is Meyerhoff. He said, development of chemistry in Europe is directly related to El-Jabir. What else should you say? Daha ne desin adam? Directly related to El-Jabir. And he wrote 70 books, and they were all translated to Latin and then to German, French, because in Europe, the scientists spoke Latin only. Because in church, they spoke Latin. So when they learned how to read and write, the schools were in church. They spoke Latin. They didn't care about French or German or Italian. Latin was the main language of aristocratic people or scientists or religious people. So Latin, everything was written in Latin. And then later on to the other languages. So they learned the use of distillation and extraction and perfume making, mostly from his books. Later on, let's get back to perfume. Sorry. The Italian priests learned the secrets of perfume. Why? Because they knew how to read and write in Latin. So when they read the books of El-Jabir and Al-Kindi, they learned that there was something called perfume, and it was extracted from the plants and some animal parts. So they started to produce perfume in 1200 in Italy. We are talking about 1200, about 800 years ago. We are talking about Sumerians about 4,000 years ago. So you can see how Europeans were so behind in science and technique. Even perfume, they didn't know anything about perfume. So Hungarians produced perfume. They called it Hungarian water. They had a queen Queen Elizabeth. She wanted them to produce, the chemists. They said, you are scientists, just produce a special perfume for me, or a cologne or something. Then the Italian perfume experts started to produce perfumes from French flowers in France. So then, because there were beautiful flowers smelling good in France, they were because of the palaces of France. I don't know if you went to Paris. If you see the palaces, they all have beautiful flowers. They have big gardens. So the kings always wanted to have good flowers around. So Italians imported beautiful flowers, good smelling flowers, and they made perfume from that. That's how France learned that there was something like perfume from the Italians. And of course, they are the #1 perfume producers in the world. Let's talk about the cologne that we use, Colonia. There was an Italian barber named Feminis. He was working in Germany. In those days, Italians lived in Germany, in France. There was no differentiation. You could live anywhere in Europe, doesn't matter. The students, they started to go to Italy, to France, from Germany, or vice versa, to Spain, as I said, to Andalus MAV schools. So they didn't have very fixed borders in the early days. It happened later on. Nationality came to the picture later because they were under the control of emperors or kings, and all the people were mixed. But anyway, so he was working in Germany. He was just barber, and he produced a liquid with little amount of perfume and some alcohol, some water, and it's called eau de Cologne because of the name of the city, Köln. So that's why we say Colonia. It's water of Cologne in Germany. Now, this is one of the first examples of eau de Cologne. It's 1709. it wasn't sealed in a glass. Now, if you look at the perfume industry, it's about $34 billion sales in the world. And probably they say in 2025, it will be about around $40 billion. They are the major, France, Spain, and Italy are the major perfume producers. And Sparta, as I said, is the best rose oil producer, so they earn about $36 million. Of course, nothing compared with the perfume, but still it is the highest amount in the world. We produce the highest amount of oil. Okay, this is the end of the lecture today. Any questions? Affedersin? Tabii tabii.
Şu en son şey hocam. Burada hani daha üzerinden geçebilir misiniz?
Burada ödev verdin değil mi sürfaktan? Ha, orada biraz daha anlayacaksınız. Now here we have just one of the examples of detergent. It's sodium sulfonate, and this is another one. But the idea is to use sulfonate to prevent formation of scum, because when it is replaced with calcium, and it's difficult for it to replace, but even if it does, it doesn't precipitate. That is the basic thing. The detergents do not produce any product insoluble in water. Therefore, they are 100% efficient. You can use almost every single molecule, but in soap, you cannot use every single molecule, because even though we say we have salt water, it's not pure water. It's not distilled water. There is calcium in all waters because it comes under the ground. We have calcium everywhere. Kireç is very common. But salt means amount of calcium ion is low and high. So detergents are not affected. That's the idea. So the idea was to produce something which would work in hard water as well. Okay?